Blunt cut metalwork, March 2nd, 2019. This video will be a little long because I'm going to discuss the steel and its capability. Early, start out a few decades ago, I do work in the field, do a lot of chopping, and of course I have to sharpen my chopper about every half an hour or so because it gets dull. And that sort of irritated. So anyway, of course I wish to have a chopper that I can chop the whole day long and it stay really sharp. And well, in the last 5 years, I do a lot of heat treating, and well, many times you keep I push the hardness to as high as possible, where it's still allowed. But eventually, when you use a tool long enough, there's going to be accident or fatigue, and damage happen. And of course the question would be, in my mind, or what I faced was how much, or the magnitude of the damage, and how much do I lose, how much in the chopper, or to edge here, how much of the height do I going to lose beside the effort of fixing. And I find out, for my personal, quest, is I want able to chop a long time, stay sharp, and able to do a job. If there's damage, at the end of the day, I can fix it. And so the length of time to fix. And for a big knife, usually you have some sort of tool. And so, unless you have, say, in the field, you have only one knife. In the field, usually I carry 3. And so, one can go down or 2 can go down. I still got the third one able to finish the day. But as far as fixing and the effort, or how much it costs, and also costs. And so, of course, in terms of tool, and you want to buy a $30 chopper. Back then, I wouldn't thinking about would pay anything more than $100 for a chopper. That would be ridiculous. But of course, you're looking for performance, but at the same time, you don't not going to pay for it. And well, what's the option? No, there wasn't that much option. So you end up with a variety of chopper out there. And the statement has always been sort of ring true, but bother me. Would be, okay, so chopper or large knife, or a lot of knife, a lot of it did dull by deformation or damage, not by wear. And it's true. It's a lot of it not by wear. But now if you consider wear at that point, or versus deformation, either mode, the wear is a slow process. But if you have blunting, well, it's if you consider that wear, because actually in the end, when you file it off or grind it off, you either wear in use or wear in fixing. And now, as soon as the edge, now you talk about fit. Now I'm going to talk about efficiency. As soon as the edge thickens, the effort of cutting to something, or cutting ability reduced, and efficiency reduced because wedging. Think of a material dynamic, mechanic, they flow through. How much the wedging, that means resistance, and push it back the edge. And now you go and say, okay, so what can steel really do? And well, there are a lot of steel out there, and so if you look at, say, early on I bought a lot of Japanese knife because they can get hardness up to 63, 64 Rockwell, but it's quite chippy. If I rough with it, it just they go from the mold would be pretty much it can resist, it can withstand the use, and if you push it beyond its yield, you're going to fracture when you do the chip. And so that became the pretty much the accepted way of deal with high hardness steel. Also become accepted perception that has always been will be true. If something really hard, it's going to be brittle. And well, I did not buy that. So all this year, I would try to make something really hard, but when it yield, it's going to go plastic. It's going to bend or ripple. That means it can move without fracture. And so that will minimize the magnitude of the damage. But yeah, if you push it beyond the yield, I mean the plasticity range, it will fracture. That would, many things would do that. But if you keep rolling soft like aluminum foil, then you don't have a knife, you have a gummy bear. So the key is you still have something that that will withstand really hard use. How hard would the use here? I show a different level. So you have a 2x4, like something like this. I mean, this is 4x4, and Douglas fir. It's soft. I mean, the junker is really soft. And then you have something like oak. It's a little harder, close to 1,000. And then you have rosewood. So if you have tool, begin chopping harder stuff. Why I keep on harder and harder? Because ultimately you hit something like sand. Silicon dioxide would be about 64 Rockwell. But anyway, but along the way for regular tool, and there's some sort of bird here, and it's just a little stick. And I will go through the demonstration. And then you go down with this African blackwood. Now we go back to that and say, okay, now you need something to chop. If you chop along, you hit little branches, a little thing, and you want to cut it right out. Can your sharp knife handle it? And if it cannot, in this case, I mean, how much damage would that be involved here? And so, after a little more long-winded here, will be okay when you use. You're going to chop, and you're going to hit something like a wire. And this is 14 gauge, which is about 80,000 of an inch here. And it's just, this is just galvanized stainless steel. It's not that hard. It's soft, but it's so if you encounter it, what will happen to your edge? Of course, when I demo, that means what I might be the impact going to be fairly well controlled. If not, so that you can compare or at least see the where something's claimed to be hard and capable of resist very hard use, and that pretty much now. I mean, my latest history with all these years would be heat treat 3.0, and I tested this night before. This is chopper here. This is CPM 10V at 67 Rockwell, and this time I list my temperature here. It's 425 Fahrenheit, and so it's not high temper. This is low temper, but it's 67. When I tested earlier, it was 68 plus and untempered. So my previous video, that was all about. I did not mention it, but anyway, I sharpened it. In this case, here, using edge pro and diamond plate, so that no edge grounding, 18 degrees precise, the edge shoulder, or the thickness behind the edge, is 12 thou. It's not that what you see there. Only though you see there was a bell grind, but the edge pro is about a little less than half, about half of that, whatever you see in here. I move this knife so that sometimes make a layer. 1/8 from the edge is 27 thou. So it's very thin. With this thickness behind the edge, it's more a pocket knife category here, rather than chopper. Chopper should be somewhere, edge thickness should be about 25 thou. So that way it have enough steel to resist to overcome the resistance of the material, such as African blackwood or this wire here. And so I got here some cheap machete here, and I also shot it at 18 degrees precise. And say, well, this is cheap tool, and I should be able to do everything, this chopper can do. And we see if that's true or it's actually not true. The thickness behind the edge of this chopper here is very thick, 50 thou. It's really thick, but when you chop something like this, or this, it will be, doesn't matter. Well, we'll see what happened to the edge. So now, I got a Rockwell tester, and there's a lot of dimple. I've been testing this blade in the process of trying to zero in the hardness. It's no less than, I would say no less than 20 times. So, but this is the internet. And you say, well, how do you know that it's true? And I said, well, it's actually 67. I said, well, 67 would be harder than 63. And I said, how do I, okay, and I got something as reference point wise and then to compare it with. So I got actually, finally, last few video I thought I got a man bug, but I lost my man bug. This is Spyderco Ladybug ZDP 189 knife. And I believe that the hardness of this knife is about 63 Rockwell. Believe, because I don't remember, or I didn't take a test of it, but it could be 64. But anyway, so what I do is I using diamond file. I rub up the edge here and put blue ink on here. I mean Sharpie, and I do the same diamond here, file it up, and rough it and put red Sharpie here. And well, the concept is very simple. First, I will take the Spyderco spine here and try to rub off because they have the scratch this way. And so if this thing is harder than this thing, it will abrade all the red marker away. And I will use this spine here to rub off the blue Sharpie. Again, you say, well, how know that this is ZDP? Again, well, I have sort of, okay, at some point there must be some trust. Okay, I will try to do a quick rub. It's going to be tough to do. I use a sharp, 90-degree spine of this blade and try to rub it. And it didn't come out pretty much because this is much harder than this. Let me put on my glasses here. Harder than, obviously it didn't rub off. It's just smearing it. Now, okay, I have to. Okay, I don't want to hurt myself here, but I'm going to. I don't have leverage. No. Too much steel. I did not rub the. I rubbed the corner, but I didn't rub the main face. It's too much. Let me try to use. There you go. I'm using this edge right here. You can see, I mean, okay. And this is the, you can probably see metal shaving off the Spyderco ZDP 189. You can see that flint, and also this corner right here. It got a braid away. So it's harder than this ZDP 189. Okay, so this is, as promised, this is going to be a lengthy video. So I'm going to switch the camera this way. Alright, this machete here, I will skip chopping the 2x4. It's because it's really thick, it can chop the 2x4 probably fine, but the 2x4 is too cumbersome, so I'm going to remove it away. Okay, I will start out. Oh. Alright, we'll try to chop the little oak here. With the machete here, and it roll a little bit. I can feel my hand, but that's okay. And I'm going to do next here is the rosewood. It's their damage, and I think if you keep right here, it no longer it roll over. But that now there's some sort of burl here. I don't remember the name, but there are good amount. Okay, I know it's really hard to see in the video. It's really thick edge here, by the way. So it's, you know, it's chopping. Think of this one, it's like a hatchet. But now this is the one that is going to be interesting here. It's the African blackwood. It's chop right there. Just one chop, and you can see the reflection and hit a black part here, part here, and it's and right here actually I think it's more than 18 degrees, really thick, 18 over here. Let me chop another one way over here and see what happens. Right there. These are just a little guy. You won't able to do I mean, not very long amount of work before it's going to. I just going through the progression here, and this is 14 gauge. Well, when you work and you run into tough stuff, I miss it. It cut it. It's right here. Let me cut it now in the front here. Okay, it cut. Where the heck did I cut? Bummer. I think I cut way out here. Let's do one more time. Let's see. Yeah, right here. Okay, found it. Right here. So it have that damage right there. So I think I should have measured this edge. This is it's like, I think it might thicker than my hatchet. But here, okay, so this is a steel, probably 1045 steel or something. I don't know. It's not that. Okay, so that, say you buy a tool here, and if you do, and this is there, it chop. This is when it chop the 1.5 block inch square African blackwood. That how much it damaged. So in other words, it won't last long. Okay, time for my actual guy here, and oh, I need to. Usually when the knife really, the edge really sharp, you have steering and you have problem. It can be a problematic. But anyway, so that's oak, rosewood. Oh, then I need to test the burr. Burr is because of the grain, it's crazy. So it could you got unlucky piece, then you end up with okay. So far this edge face that. It's a rough right here, I guess. Yeah, there's something there. It hesitates. I have to clean it though. Let me look. A lot of times this thin of an edge, then you end up with a ripple. And so far right now I don't see anything and except the sap of the rosewood. Alright, so finish the top part, the African blackwood. Okay. the edge is thin, but actually it's important to see. It's right here. You can see it. It ripple, it bend the other way. As I'm saying, the edge way too thin, and it actually ripple, bend the other way. Right there. No chip, bend. So as far as the common knowledge, talking about the hard steel, really high hardness steel, will be very brittle. Well, this thing is a deformation of plastic. It's moved. So there's a limit how much can move. I mean, the stuff. One carbide can move close to the other carbide spacing. But then after that, you end up with a pile up. That's why if it roll or ripple big enough, it will, in that case, it will chip away. Time for it to face this wire, just like the other guy here. Let me chop it right in the middle here. Let me target it. Okay, I tried to target, but when it blew. One, two, three. That was funky. So, 3 chop at that place. A lot of time when you hit these, cut these things, you end up with steel of the wire stuck onto the edge. Okay, let me use the black block so you can. Okay, there you go. You can actually see something right here. Two little things right there. That little flint. Another chip. It's a sideways movement. It's sideways. It the edge gets pushed in top of ripple or bent over sideways. It's very, very small. Yes, I know. I have to move it a little bit so you can see there, hopefully.